Okay, let me start off this way. So today we're going to talk more about variables and numbers and how they work. And we're going to talk more about selection statements, which we started last week. And then at the end, we're going to talk a little bit about repetition, or loops. So before we start the new material, do you have any questions about the homework that we did today?
I just have a problem with multiplying up on the big operator. Very interesting.
Can't multiply. Yeah. So the screen is going data back to that. In order to multiply, abstract, multiply, or divide, you have to have a numerical data type like integral. So you have to get it a number that way. You're going to multiply. Which one was it on?
What's all about?
Okay. So for the ones you want to get the user input as an integer value, then you can multiply and do addition and all that stuff. So I would do something like that. I would say, enter the month. Then I would say something like int month number, whatever it is. And then I would say cn greater plus number. That would just be right down to if you're running into trouble, you can get help by emailing me. Pretty late, and we'll have to queue. It's also a part of help in the STEM Center. I was going to on the home page here. You look down here at tutoring resources. I was looking at people that are in the STEM Center. For instance, on Wednesdays we have Steve Hodges there from 2:30 to 3. He's an instructor, or he can help you. There's also some tutors that we have. There's on Wednesday from 3 to 9 we have Chris in the STEM Center. So there are hours there. And also in the morning there's some time and James is available. So get help there. And sometimes there's CI's lab assistants available. And we don't have those posted together to do that. And also we have Mesa tutors that are available on time. So it doesn't look like they posted that yet either. They will. So we do have quite a bit of tutor coverage already. JD, I was curious if fast practice was the out expression or this part here, the whole thing. The whole thing is not as a statement, it's in a semicolon.
So is the bad practice supposed to see out statement and the CN statement on the same line?
Yeah, each statement should have its own line.
Okay.
That's style. I guess that's the same thing as practice. Bad practice, bad style.
Yeah. Okay.
Well, Well, in minimal practices it works. And then there's size to that.
Yeah. Would you drop warnings and something like that?
I might, but I'd probably give you a warning the first time unless it's been a while and you should know that already. So, okay. So probably I'll just give you a warning.
All right. Take your word for it.
That's a problem.
True.
So, you know, I may not even say anything about it. Do the app.
Well, yeah, I have some now, I know.
Yeah, exactly. That's smart. Any other questions on the homework? So what was the, yes? Okay. So, tutorial or review? Review. Okay. So, write an expression that results in a string consisting of the 3rd through 10th characters of the string S. But how do I extract part of the string out of another string? Yeah, it's the substring function or substring, right? So I would say, to use the substring, start with the name of the string, which is what it is probably. Use a dot as a dot notation. And say the substring function. The substring function takes how many numbers for it? 2, right? Separated by a comma. So I want to start with the 3rd through the 10th characters. So the English is sometimes tricky because of the starting at 0, but the 3rd character I think would be 2. And then we want the 10th characters, and so I think that would be 9. We'll see if it agrees with me or not. I just readjusted. Pardon me? Oh, you're right. That's the wrong number right there. That's bad. I already made a mistake. Because I want the 10th character, so 10 subtract 3 is 7. So this should be 7 here. Is that right?
8.
8.
Could you include the 3?
Pardon?
Include the 3rd character.
Oh, include the 3rd character. Yeah, oh yeah, right. Subtracting the 2. Thank you. Does that work? Yeah. Oh yeah, so the results say, hey, the expressions do not need semicolons. This is even a somewhat useful remark. Unlike some of them. So it's getting better. And then we hit submit again. And says, okay, so thank you very much. You guys bailed me out and we got this one right. Okay. So it goes back down to if I had some garbage string. If I had A, B, C, D, E, F, G, H, I, J. That's number 0, 1, 2, 3, 4, 6, 7, 8, 9. And the 3rd character, which is the C, I think that's number 2. Then we want the 10th character, which is the index 9, so it's 9. We want to include the 2, so we would have to have 1, 2, 3, 4, 5, 6, 7, 8 characters there. So that can be a little tricky because of one simple little thing that starts at 0 instead of 1. And we're used to talking about it as starting at 1. But in C++, a lot of lists of things like strings start at 0. Okay. Any other questions on the homework? It's my turn to ask you some questions, okay? There's no quiz this week, so you'll be happy to notice that. Good? last week? No, so it's a good thing there isn't one this week. So for this code, what's the value of X? Okay, this code, I'm talking about this code right here. What's the value of X? How many people remember what the ASCII code is for an A? Pretty good. It doesn't really matter in this case. This is some number called 100. And this is some number called 97. What's the difference between them? So if I take 3, that this is really integer. We're doing this integer characters here. That's really a 3, and I add 3 to uppercase A. What am I going to get as a result? Yeah, uppercase B, right? So I don't even have to know what the ASCII code is. I just have to know that difference is 3 because it doesn't order. Anybody answered on that one? Okay, so lowercase b happens to be 100 in the ASCII table. And lowercase a is 97, so if I take 100 subtract 97, we get 3. And uppercase a is 65. So 65 plus 3 is 68, which is uppercase e.
We're supposed to memorize the ASCII table.
No, we didn't need it for this problem.
We need to know what any of the language represented.
Right. Because this could have been 1,000, and this would have been 997. In that case, because it's 3 before. All you really need to know is that that's the difference.
Oh, I see. That's better.
But if you wanted to memorize it, there's only a couple things you have to memorize. Uppercase A is 65. So what is uppercase B? Lowercase a is a 97. So lowercase b is 98, and so on. That gives you half of the table right there, which is usually a structure that you get a set jump from this your little part of the ASCII table. Yes, sir. Rodman, right? So how do you know that if you don't know what the ASCII code is, how do you know what it is? Well, A, so we have A, B, C, D. Or you can just pick a number. Let's say that D is 4, and A would be 1 man. So the difference with 4 minus 1 would be 3. So you do have to understand the arithmetic part, which you do already, and I know you do. So that's really all you have to do. And you have to know that they're really represented as integer numbers inside the computer. And because of that, C++ lets you do these little arithmetic tricks with characters. So that can be useful. So you want to write have you heard of a Caesar cipher? Where you just shift the letters by a couple each time? Shift them all the same and you get a different message out that's hard to read. That was attributed to Julius Caesar way back in the Roman Empire days. So you can, automate that process. Okay, let's do this one. Let's display by this code. He says 3. How many people think he's right? Only 3 people. How appropriate. How many think he's wrong? Only 1 person. See? And how many people don't know? And the others are just non-responsive to that. Are you alive? Okay, so let's work it out. named stir. And on this first line, I put ABC in it. And then on the second line, what kind of statement is this? What's the name of that kind of statement? That's good. An assignment statement. How can I tell? It has an equal sign in it. So an assignment statement, what sign do you get first? The right-hand side or the left-hand side? Right-hand side is right. So over here we have the value of stir, which is what? ABC. What's the little plus sign mean when it comes to string? I guess we can't have combination. It's the concatenation operation. It just joins two strings together. So this says take 1, 2, 3 and add to the end of what ABC, or whatever is in the stir right now, which is ABC. So after that line, we have that inside of stir. Then we did concatenation last time. Okay. So now I have ABC 1, 2, 3 inside of stir. So now I need to find out this third statement, what's going to print out. So notice these parentheses here. You always do what's inside the parentheses first, right? First we have to find out what's the length of this string. That's the same thing as saying how many characters are in it. How many characters are in that string? 6. So if I take 6 and I subtract 1, I get 5. Now this 5 is what's fed to the beginning part of the substrate function. And the first argument to the substrate function is the index. Good. So if we just go 0, 1, 2, 3, 4, 5, there's that 5 we were looking for, so it's going to start here. And the second argument of the substrate function is what? How many characters? So I'm going to start at position 5 here, which perhaps is 3. And how many characters? Just 1, so I pull out the 3. How many people think that Judy will write down? All right. You get more support all the time, Judy. So in order to solve these month problems, you have to understand this about substitutes here. You may have trouble with the months problem. Yeah. 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 I was wondering if it might be too hard. But you got it. So you got it. It's not too hard. It's tricky. Yeah, it was tricky. Okay, so here's if statement, the other thing we talked about last week. Anyway, if I was to have a quiz, it'd be things like this. So, what's the value of x when this code is done? So it starts out, okay, let's work it out. There's some disagreement on whether it's 52 or 42. All right. So we have this variable x, and it starts with a value of 40, thanks to the first line. What's the name of this statement? What kind of statement is that? Pardon me? It's an assignment, but it's also a declaration. So it's a declaration and assignment combined together as a shortcut coding. So it starts out and there's 40 in the x box here. So is the value of x less than 10? False. Right? So x less than 10 is false. So if it's false, what part of the if else do I execute? The else part. So that means that I take the value of x, which is 40, and I add 2, and I get 42. Imagine that. And then I take the value of 42, and I assign it to the variable on the left-hand side, which at that point changes that 40 to 42. Well, it's 42. Okay. Everybody okay with that? All right, good. Anybody try pair programming? How was it? Pretty easy? Helpful? Okay. Here's a little video of what pair programming should look like in practice, and I think it's worth watching this. Anybody had trouble with arithmetic in the C++? How did it feel? Was it different in arithmetic and calculators or anything? A little bit? No?
Maybe a little bit.
A little bit?
Not much, though.
Yeah, well, it's kind of like that. All right. Well, let's move on and talk some more about arithmetic. Just as a review, C++ uses these operators for arithmetic. There's the plus for addition, the dash for subtraction, the star for multiplication, the slash for division. That's just like a calculator. Most people are pretty comfortable with those 4 operators. The 5th one is the measure after integer division with the modulus operator. So we write these arithmetic expressions that are combinations of numbers, variables, and operators. So on this line, we have an assignment statement, and we're declaring 2 variables, area and radius, and we assign the value 0 to area, and we assign 4.3 here to the radius. And on the next line, after we're done there, we take the radius, we take 3.14159, which is approximately pi, and multiply it by the radius, and then by the radius again. So that gives you pi r squared, right? So, which is how you find the radius of a circle. So this is an arithmetic expression on the right-hand side here, because we're doing some arithmetic. It's not a complete statement, because we still have to finish it and assign it to the area when we're done. So technically, it wouldn't even have that stuff like over here. It would just be this part. It would be the arithmetic expression. Okay. So just like in algebra, what you're used to, the multiplication and division are performed before the addition and subtraction. So what you've learned through grade school and high school still applies. PEMDAS, right? If you want to change the order of an operation, use the parentheses, P and PEMDAS. But there is some slight differences in C++. It's really more complicated. When I do a 7 divided by 2, I don't necessarily get what you think. You don't necessarily get what you think you're going to get. What kind of a number is 7? Pardon me? Yeah, it's an integer data type. I should say, what's the data type? So it's an integer data type, and it is prime, which is cool. So it's an integer data type because I don't have any decimal points with it. So the compiler would store this as an integer data type in the source code at the bottom. And then what's the data type of the 2? An int. So when we have an integer on both sides, then we perform integer division. So it comes out to be 3. And in an integer, there's no room for a 0.5 or any other value like that. So that just goes away. There isn't any. If I want to know what the remainder is, then I use the modulus operator. How many times does 2 go into 7? 3 times. So 3 times 2 is 6. I subtract the 6 from 7, and I get 1. So therefore, the remainder is 1. So we just say 7 mod 2 forms the integer division, and whatever's left over from that, we'll report it. We'll say that it'll be over. We can use more complicated mathematical operations. We can use functions for more complicated mathematical operations like square root or POW. And the inside of the function here, we have a parenthesis, which always gives the value in first. So we take the 3.0 and multiply it by 3 and get 9.0, if you will. And then we take the square root of 9 and we get 3. Right? The square root is different than square, so it should go into that track. For these functions, we need the CMath library. There's a whole bunch of CMath functions that are available from absolute value and down to square root and things like that. So you can look through that if you're curious. We talked about some of the more commonly used last week. When you have an arithmetic expression, they're performed in the same order as algebra, where it's parentheses first, then the function calls which have parentheses. And then there's the unitary operators. Then there's multiplication and division, which includes modulus, because modulus is a form of division. And then addition and subtraction at the end. So any questions about arithmetic in C++? Okay, so there's another way that you can represent numbers, double numbers, or floating point numbers in C++, and that's writing an exponential notation. How many people have taken chemistry or physics? So are you familiar with the term scientific notation? How many people have heard of scientific notation? Okay, so scientific notation is where you just take a really big number or a really tiny number, and you write it in a special formula, and when it's in the scientific or exponential notation form, then it's able to be manipulated more easily. So to get into exponential notation, what you do is you express repeated multiplication using an exponent. So if I have 10 times 10 times 10, rather than writing that out, which is kind of repetitious, I just write 10, and then I superscript the 3. Maybe there's 10 different 3s that are multiplied together there. So what's happening is we have the base, which is 10 here, and 3 is known as the exponent value. So when we read this, we refer to it as 10 to the third power, or because the third power is often cubed, you might say 10 cubed. But it means that it's 10 times 10 times 10, which is the same thing as the 1 followed by 3 zeros. So that's the idea of exponential notation. Questions so far? So you can convert a number to exponential form and standard, between exponential form and standard form, and it's just a matter of moving the decimal point to the right or the left. So as a little rule, if I have 1.234 times 10 to the third here, all I do is I take that decimal point and I move it over 3 times, because that's the 3 superscript there, and I come out with 1, 2, 3, 4, and the decimal point is now 3 into it. If I'm a negative power, then I just move to the left. So if I have 1.234 times 10 to the minus 3, and I have to add some zeros in front of it and move the decimal point over, so I'll end up with 0.001234. Any questions about exponential notation? Okay. So here's some examples of decimal form, exponential form, and then C++ form. You should know this is a little different, because writing times 10 to the some power with the superscript is hard to do on the keyboard. So instead, we just substitute E. So E means exponent, but it also means times 10 to the. You can think of it that way. So we have negative exponents, and we have positive exponents. So here's a negative 1, and here's a positive 1. Usually we don't bother with the plus sign on the positive, but you can add it. So questions about exponential notation? Okay, let's do an activity. I want you to take out a piece of paper and put your name on it. I want you to do this exponential notation exercise here. And when you're doing that, I'm going to call a roll and do some exercises here. You should all the decimals what they have. So as soon as I'm calling a roll, you should go to the exercise. Oh, Gina Alvarez. Manuela? Sarah? Thank you, Sarah. Bradley? Alexander Burnett? Alexander Burnett, wonderful. John Nelson. Thank you, John. Leonardo. Bill, you're here. Blake. Rodney, you're here. long way. Thank you. Warren? Thank you, Warren. Andrew Hoff. If you use places, there's space. Andrew Hayer. Alex. Junior, you're here. Gregory. Christina. Christina Packer. Antonio. Thank you, Antonio. Brad. Thank you. Thank you. Mark. Matthew. Matthew, please. Amanda. Thank you. Kevin. Diego. Stanley. Stanley. And Edward. Thank you. And Steve. And Richard. Did I miss anybody? Okay. That means that everybody's properly enrolled. So what I'd like you to do now is take your papers. Look, you've had plenty of time to fill those out and even have them out. Exchange it with another classmate. And actually, you have to exchange it. Just verify it with the other classmate. And make sure you both agree that they're correct. Well, it gives the difference. Okay, so let's go over these. So the population of the world, about 7 billion or so, probably a little bigger by now. So the standard exponential form would be 7.30639. Okay. Now, if you wrote it as 73066, that is still something you could type in a computer and it would understand it. It's just not the standard form, which is not what I asked for, but just so you know. This is what I'm trying to get to. So you always have one digit to the left of the decimal point. Okay. So the distance from the Earth to the Sun is 92 million miles and some, right? That isn't bigger than this. So 9.296 e to the 9 is count. 1, 2, 3, 4, 5, 6, 7. So 9.296 e to the 7. That's the number I was looking for. And then the human body contains a bunch of organisms, cells in it. So we got 6.0, if you will, e to the 3, 6, 9, 12, 13, using the 13th power. And the second estimate is 9 e to the 13th power. So you have to actually put the decimal point, you type it into C++ or even below. The mass of the dust particle is not very much. So that's going to be 2.6 e to the minus. And I have to go 1, 2, 3, 4, 5, 6, 7, 8 decimal places over. So it's minus 8. Is that a 6? Yeah. So, like so. And then the length of the shortest wavelength of visible light, violet, is 1, 2, 3, 4, 5, 6, 7. So 4.0 e to the minus 7. Everybody good with those? How to do it? Yes. No, it doesn't. Either upward or upward is acceptable. It's highly acceptable. So, one question you might be wondering is, what's the largest value that we can represent as a double? And the answer is 17, followed by 307 zeros, or 128 followed by 308 zeros. So, put it in context, how big is that? So the current estimate of the number of atoms in the universe is between 1 times 10 to the 79 and 1 times 10 to the 81st, depending on which way you estimate. So you can easily include all the atoms in the universe in that number of 17 followed by 370. But you can store a pretty big number in a floating point in C++. There's this term the mathematicians use called the Google, and that means it's 1.0 of e to the 100th power. And Google, the company, took its name from this Google mathematical number, and they had to change the spelling of it so that they could copyright it. Right? But it's really where it came from. So type double is no problem in handling really large numbers, or really minute numbers too, running.
So that's a double variable?
That's a double floating point variable, yes.
A double is a number with a decimal point. Yeah.
So all of these that we're dealing with here were type double. You can force it to be a type of float by putting an F after the number, then it was stored as a floating float number instead. So there are two different kinds of floating point
Data types that are commonly used in C++. The float, which takes 4 bytes of memory, and the double, which takes 8 bytes of memory. The double is twice as good as a float because it's twice as precise.
and it has a bigger range. The float only goes up to like 10 to the 40 something power, so you can't count all the atoms in the universe with it. So, what large number in a real world that you may have some experience with
Cannot be represented by type double. Pardon?
Infinity.
Infinity. Wow. Yeah. So infinity, of course, is bigger, or negative infinity is more negative than that, but yes. So infinity would be bigger than that.
So, in your own experience, any other ideas? Pardon? 5. 5? Pi is 3.14159 and so on, right? So that's within the range. So this is an infinite number of decimal points?
Yeah. So it's an irrational number. Is that right? Or is that the wrong term?
Yeah.
Oh, okay, thanks.
I saw another hand in the back.
An idea of things that you've experienced in real life.
The only thing that I can think of besides infinity, which I don't have a lot of experience with infinity, is the certain politicians' egos. Might not be able to measure that with the type level. Andrew? Yeah, so I'm not asking how many decimal places there are. I'm asking the range of the number itself.
That is encompassed within the double. It's just not precise.
Can I be represented by double?
Imaginary number, yeah. Not really. That's a kind of a compound number because it's got an imaginary part and then a real part to it, right? So you have to have a more complicated data type than that true that is real. So good. Imagine. Okay, let's talk about decimal formatting. So let's say that I have a program like this. And I'm going to paste it into my trusty text pad here. And I'm going to save this to my desktop. The desktop's just a convenient place so I can actually look and see that it's there. And I know I saved it right with the correct CPP extension. because it turned color. It gave me the syntax highlighted. This is what most text editors will do. Not all. When I compile this program, which I can do with Control-6, or if you prefer to use the menus, remember the tools, external tools, compile C++. And when I do that, it compiles it and says, hey, the tool completed successfully. Then I can go ahead and run this as well. It says, what? Price is 78.5. I wanted it to say 78.50. What's up with that? Well, by default, Cout will not display any trailing zeros. But sometimes we wanted to display a trailing zero. Like if we're in business, usually you do things, you express cents or portions of a dollar as .xx, whatever they are, 2 digits. So sometimes we want to force it to print out 2 digits so that it'll look like their financial applications. In order to do that, we use what's known as a magic formula here. We say Cout fix and set precision. So I have to put this before I print it out. And if I want to be a super neat freak here, I'll just do that. So I say Cout less than fix, less than set precision, and that will give me a different result when I compile it and run it. Oh, dang, the set precision was not declared in the scope. So what does that mean? What does it mean when it says something was not declared in the scope? Yeah, it doesn't know what it is. Yeah. So that usually means that we need to add another library. So I add a second library for set precision, which is called IronMid. Now when I run it, it compiles it. Good. Let's try it again. Must be good. And I run it, and I got 78.50 now. So I got that extra decimal place that I wanted. So if we look at the code, the fix means put it in the standard fixed format instead of exponential notation. So the choice is our exponential notation of the standard fixed format. So fixed forces this into the standard fixed format. And then set precision is how many decimal places do we want to display. So to the right of the decimal point, how many characters or digits. So if I change this to like 3, sometimes any business majors here. So sometimes people in business, want to know something out to the 10th of a cent. So now I'm going to have 3 decimal places. So I can have as many decimal places as I want by just adjusting that number of set precision in the number of decimal places.
What if you took this manipulator out?
Okay. So I can leave that. Like that? Yeah. Wow, must be good. Wow, that didn't work, did it? Now what if I made this to be 4? Oh, good. Dang.
Oh, no, good.
Well, you gotta have both in order to make it work.
That presentation doesn't work unless you have the same thing.
Yeah. There's another little trickiness about it, which is why I'm kind of presenting it as a magic formula. Use this and you will give decimal places. So when it's back, it will have that. Iowa in here. And that is going ahead and show however many decimal places we take. Any other questions? So, all files, all the updates of that? After that, yeah. Okay. So what you said is it's set. If you want to unset it, you can use these commands. So I can say unset of iOS _ base float field, floating. It's kind of like scientific notation, and it's set precision 6 because it's multiple 6. Okay. Any questions? I want to talk to you about some magic now and concept. So, when we declare a variable, we're setting aside space in computer memory. So it's like making a little box where we store data. And it's a pretty good analogy because, you know, your memory is a big, you have this big long list of memory, so we're just setting aside an area. Let's think of it as rectangular, and we're calling this A here. And then when I have an assignment statement, I take the value on the right-hand side and I put it in the box for the variable on the left-hand side, so now A has the value of 1. I can also declare and assign a value in one statement. So when I do that, I first create this box named B, and then I take the value of A and put it in the box B here. And when I do that, then I have two locations in memory, two boxes, if you will, and they both have separate values. Everybody okay with the way the variables work here? Hopefully this is review. So there's this thing called a constant variable in C++. This sounds a little strange because how can something be both constant and variable at the same time? Sounds like an oxymoron. So, but it's actually quite useful in C++. So to take a variable, like int my constant, and make it a constant, I put the keyword constant in front of it. So all I do is I add this word constant. It can be done for any of the data types we've used so far. And so int, doubles, strings, whatever, it's all going to be constant. If I take a constant and I try to, if I declare constant, put it in code here. And then I go and I try to assign a different value to this compile to show you that. As a warning that we haven't done anything with on constant. So I take care of that when we have this compile. Must be good. So if I went and I tried to change the value of my constant to something better, like 42, at that point, the compiler won't let me do it. It says, there's an error assignment of read-only variable my constant. So it's the compiler's way of saying, don't do that. Or I won't let you do that. So we have to assign a value the first time we declare the constant variable because we can't do it later. Can't be changed. And once it's assigned a value, it can't be changed. And it has to be assigned a value when you declare it as well. Good question. So let's say that we had this, let's say we got hired to change the cases payroll program. And if you make a mistake in the payroll program, somebody's going to be mad at you, right? Either the workers that they get paid right or the boss because they pay too much. So you've got to be right on the money here. So you come across this part of the program, and there's these numbers in here. And you know that the numbers are important to the program, but you don't know what they mean. So if something works, but you don't know what it means, it's magic, right? And that's the definition of magic, kind of. It's some magic thing. So these are called magic numbers because they're important to the program, but we don't know what they mean. It's not that we can't figure it out. Like, what does 10 mean here? So $1 means $10 an hour. That makes sense to people? Yeah. Get a group of 30 people, you know, you can probably help figure this stuff out. What's the 40? Hours per week. Hours per week. So what's the 0.5? Overtime? Yeah, pretty good. So it's the amount extra you get for overtime, right? Or over 40 hours per week. So we can figure it out, but it takes us a while. Sometimes it takes a long while to figure out what those numbers are for. So it's much better style if you instead assign those numbers to a descriptive variable name, like wage, 10, overtime bonus, 0.5, hours per week, 40. And then when you come across this code here, it's documented what all the numbers mean, and you know right away without spending as much time. So these are constants to avoid magic numbers. Another advantage of it, if I change the wage, like next year, I think it's going up to 11, is that right? Anyway, no, 11. So next year it's going up to 11. So next year, I just change that 10 to 11 and all the calculations will work inside of my code. I don't have to search through there for every 10 in a program that might be thousands of lines long. And say, does this 10 reflect back to the wage or is it some other value of 10? You know, so things can get pretty confusing unless you do these kinds of things. So it's a matter of style. And don't have magic numbers in your code. Always assign it to a constant variable. And the constants, to emphasize that the constants are all the case with underscores between them. And these examples here. So for instance, here's our favorite pi. And here is some approximation of pi up to some number of decimal places. The questions about constants or magic numbers. It seems kind of tiring. So I'm going to give you a breakdown, but first 2 minutes, you need to take all those numbers that we did before I erase it here, and just write a constant variable that you use for each one. I'll give you a hint, they're all constant values. So make up a name for them, and then do a break. So I think this is a 2-minute activity, so 12 minutes from now, you should be done with this exercise and well rested. Okay, let's get started again. So, what I'd like you to do is, you need to go over that last exercise we did before break. Anybody feel the need to? So everything's going to start like this on double, because they're all doubles in scientific notation, or it could be a float. So float or double here and there. And then you make up a name for it. So the last exercise, population, so you would use all uppercase because it's a constant. And you have is equal to 11.306 e to the 9. That was declare constant variable. Questions about how constant is done? Oh. That's a good point. So yes, I think you would, but I'm not positive. So if you're not positive, what do? You ask the compiler to tell you. So here is a constant double and pop equal to 37.306 e to the 9. And then I want to just print out pop. And if I change this to a plus, okay, so what's okay with it? Well, C++ will take the double on this side and convert it into a float. When I run it, you can just see if there's an end down here. So 7.306 e plus 09. That's how we play on that. So any questions about scientific notation or constants or magic numbers? So starting with the next assignment, I expect you not to put any magic numbers in your code, except I do allow 4 magic numbers, -1, 0, 1, and 2. That's the only ones I won't complain about. You don't have to put any magic numbers in, but I do allow those just because they're such complicated numbers. Okay, so moving on now, let's talk about assignment operators. So remember, whenever we have an equal sign, it's an assignment operation that we're doing. But over on the right-hand side, you can assign to the variable on the left-hand side. So we can combine a declaration of a variable and an assignment all in one statement. And the equal sign, as we've learned, does not mean equality. Here we're talking about taking the value of the right-hand side and assigning it to the variable on the left-hand side. So here I can start out and initialize a variable named sum here to 25. And then I can do this next operation here, which is something that you probably have never seen in algebra, right? Any mathematicians in here? Did you ever see something like that in algebra, where I had different values on both sides of the equal sign? No, that's not how C++, what we're doing here is we're taking the old value, we're just putting a new value in there. So first I read out the value of sum, which is 25, and then I add 10 to it, which is 35, and then I take all of that from the right-hand side and assign it to the variable on the left-hand side. That's how we do arithmetic in C++. Okay, assignment operator. So that's the standard assignment operator, but it turns out that C++ has these shortcuts for assignment operators, or what they call compound assignment operators. And there's this form where there's some variable, and then you have an operation like plus, minus, multiplication, division, equals some expression. So instead of having x is equal to x plus 3, what I can do is I can say x plus equals 3 instead. What do you think? Like that shortcut? Or do you find it confusing? How many people like that because it's less typing? And how many think that's kind of confusing? Yeah. So you don't have to use it. I mean, you have to know what's going on, but you don't have to use it in your code. It says to use clear. But these are equivalent statements here. Okay. So there is compound assignment for each of the arithmetic symbols here. We got plus equal, we've got a dash equal, we have a times equal, and a division equal or slash equal, and then even a mod equal. So we got all of them covered here. So over here on the right, if we have x plus equal 3, for instance, that's the same thing as saying x is equal to x plus 3. So you can write it out in longer form. Over here we have x minus equal 3, it's the same thing as saying x is equal to x minus 3. So x slash equal 3, same thing as x is equal to x divided by 3. So this is compound assignment operators. Really useful if you want to look the obfuscated C++ code controls. Okay, so we have a variable like int c, and we assign it a value, and we can actually start out at 0. And then we want to add 1 to c, we can say c is equal to c plus 1, right? And the shortcut assignment operator for this is c plus equal 1. So it turns out that adding or subtracting 1 to a number is a very common operation in computers. Not as adding 1 or subtracting 1. And so because of that, there's even a more shortcut for adding or subtracting 1. If we write C++, then that adds 1 to C. So remember in the beginning I told you, I'd tell you the joke of where C++'s name came from? That's where it came from. I just think it's a good joke. A little bit of dirty humor in there. This is known as an increment operator. It turns out you can write it in 2 different ways. You can write it as C++ or ++C. You can also subtract 1. I can do C minus minus. I think there's been languages named after that too. Or minus minus C. Okay, so this adds 1 and this subtracts 1. So when you have a ++ after, this is, anybody know Latin here? Latin is not one of those languages people use much anymore. Okay, so this is known as the post increment. Post means after. So post-increment operator. And what do you guess it's called if it's before variable? Exactly, it's a pre-increment operator. So same thing with the minuses. This is the post-increment, and this is the pre-increment. So the pre and post here don't just mean that that's where the symbols come. It also helps explain how they're evaluated. If you use post-increment, and you're using the variable c in some expression, then the plus doesn't come until that statement's completed. And whereas if you use the pre-increment, you add the number 1 and then you use it inside of the statement. So it has a slightly different meaning, which can get you in trouble if you're not aware of it. That's why I have to talk about it. Let's say that I have this code right here. Are you required to put the return 0 on, by the way? Not for main. For other functions you would. But for main is a special function because it's where every program starts executing with main. And so because of that, if you leave it off, it'll add one for you. It'll add a return 0 and a compile. So it's not 100% required. So here we have x is equal to 5. And then we have y is equal to x plus plus. So the question is, what does this print out on line number 8 there? Does it print out what's the value of x and what's the value of y? On line 8. Anybody want me to get them? Okay, so x is equal to 5 and y is equal to 6. How many people think he's right? Wow, 1, 2, 3, 4, 5, 6. Got a good rep there, baby. A lot of people bought into that. Right, Ron? How many? No pressure. How many think he's wrong? Just one person, 2 people. So 6 and 2 there. Not bad. Anybody that people think he's wrong with, what do you think is going to come out? Andrew? So x is going to come out as 6 because of the plus plus, and y is going to come out as 5. I think that, okay. So you're subtracting your vote from before. Okay, so you're down to 4 here, because it was a good explanation. So now, how many people think it's this one? 2, 3. I see that, Angie. Here. Okay. And how many think this is wrong? 1. All right. Interesting. So how do we find out these things? Let's try it. Let's compile it. Hey, compile must be good at turning it in. Then I run it. I get x is 6 and y is 5. So Andrew had her. Good job, Andrew. But why, though? Let's take a look at what this means. Because this is the post-increment operator, then the plus plus is not added to the x until after the statement is completed. It's the same thing as saying x is equal to x plus 1 on the next line. So the equivalent of that goes there. So first I'm going to take the value of x and assign it to y, and then I'm going to add 1 to the x. So that's what the closed increment does, or the closed decrement using minus minus. But if it's free, I'm just demonstrating this before I go on. So there we got x is 6, y is 5. Well, the same thing we had before. But if I use the pre-increment operation, where I take this plus plus, and I move it over before the x, that means that I'm going to add 1 to x like it was on the previous line, and then I'm going to assign it to y. And then I get x is 6 and y is 6. So first it takes the value of x, it adds 1 to it, and it takes that value and assigns it to y. So it's the same thing as having x is equal to x plus 1 on y. Y gets x. That would give you the same result as if we had the plus before the x. Anybody? Yes, ma'am.
Can you draw the syntax plus 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 plus? Or was that doing the syntax there?
So when you get those kind of questions, what's the best way to find out? This is a good thing to do. Try it, right? And so you confused it enough there. I mean, would that add 2? Is that kind of what you're thinking?
Kind of, like add it to y and then increment x.
So B plus plus is right there. So how many people found that confusing or make their head hurt? Confusing, yeah. So the best thing to do is don't use the plus plus or your plus as part of another statement. And just keep it on its own line. Let's do something like this. It's plus plus, and then y is equal to x. And it's really clear what's going on, right? You're never going to make a mistake there if you go line by line. So let's kind of be more over. Hey, any questions about pre and post increment or decrement? It's why you get one from x, then its own line. That has x plus plus on somewhere. It does. Okay. That way you can't get confused between the two. All by itself, isolated. I actually use the plus plus operator quite a bit, so we try to keep it just on its own, in its own statement. Okay, so I think we'll skip this activity because I already went through it. How many ways can you add 1 to a variable in C? C is equal to C plus 1. C is equal to 1 C. C is equal to C plus 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 C, and a lot of different ways. Okay, I want to talk about typecasting. So every piece of data in your program, like one or whatever, has a data type associated with it. And sometimes we need to convert from one form to another. This is known as casting. So cast just means you change the data type of a value in some expression. So usually we're talking about integer values, though you can do other kinds of casting, which we'll get into later. C++ will automatically cast one value to another, which is known as implicit casting. So when Paula asked your question about, I don't know if we go back that far. Now, what would happen if we had a float top and we had a double on this side of it? So C++ automatically, we implicitly change it from a double on the right-hand side to basically the variable on the left-hand side of the float, which is a different size of data. So here's an example. Oh, so sometimes, so C++ does it automatically. We can also explicitly tell C++ to do that to a particular value. It doesn't change the variable value, it just changes the value as it is in the arithmetic expression at that time. So the way we do it is we put the data type inside of parentheses. As an example, here I have a double and I've decided the value of 2.99999. Then I want to, on line 7, I want to take the value of A, which is 2.99999, and I want to just make it 2. Get rid of the 0.99999 part. So the easy way to do that is I just cast the 2 in. It only changes the value of A right here in this part of the expression, or right here. And it doesn't change the value of what's stored in the variable, so it's only temporarily changing the value just for this expression. Then I take 2 and I assign it to B, and I'm going to print out the value of A and the value of B. Take the file from some here. So A came out to be 2.9999, but didn't change, but the value of B became 2, because we temporarily changed A on line 7 into an integer value variable of 0.9. Everybody get that? Nice. Okay. So that's occasionally useful. Because it doesn't change the value of the variable, it just temporarily changes it. One use you might have for a casting is to change the to fix a problem we might have. So let's say that we have int degrees f is 70, and I want to take 5/9 and multiply it by degrees f minus 32 so I can convert to Celsius. So what will this print out? Any guesses? Okay. Yeah, so it'd be about that if it was Celsius, right? Yeah. I think so. So the file must be good. And when I run it, I get that the degrees F is 70 and the degree C is 0. It's supposed to be 20. What's the matter? So we decide to end you. What's the matter? All right, we're going to have a
Midterm in 2 weeks, and you can expect to have a question like that on the midterm.
Everybody get shirt late. Yeah, so 5 is an integer value and 9 is an integer value. So how many times does 9 go into 5? 0 times. So I get 0 out of that. 0 times anything is 0. So it's a common mistake that people make because of the integer division property of C++. How do I fix it? Well, one way is I can just, hey, I'm going to change this 5 here into a double, but just temporarily. So I'm going to put double in front of it. File looks good. and now I get 21 seats. So Blake was right. As long as we fix the way on the list of things. So sometimes casting is used for that. What's another way I could have fixed it? Oh, I could have rearranged it so that there was a double in there somewhere.
Some curious of you didn't have it before the cast.
Oh, no, the casting takes precedence over division.
Okay.
So I guess we have casting at the top of the pen dog thing.
Yeah. So that's 5.0 divided by 9.
Yes. And anytime you have a double with the integer, it automatically promotes the integer to a number. It's implicit casting occurs at that point. Another hand over here. Yes.
So the trade, when you, because the beginning is really positive, and you're declaring it.
Oh, you think it should have came out of yes, that's right. You can see that because I assigned it to an integer variable, and so that cut off the point whatever that was after the 21. Yes, sir.
Where the user just find the variable double, that would avoid doing having a problem with it.
Okay. Well, like degrees C here,
Yeah.
I could have made this a double. And then I wasn't needed to say the word double in parentheses here. And I saved myself like 2 strokes, you know, 2 characters in the typing. In fact, it's a shift too, so that's 4 keystrokes there. So would this fix it? How many think this will fix it? Okay, how many think it won't? It's about 50-50. Let's try it. Yeah, it's because the right-hand side occurs before you assign the value to the variable on the left-hand side. I'm going to use the 5 divided by 9 first, because division and multiplication at the same precedence. Well, actually, first I'm going to take 70 and I'm going to subtract 32 from it. I'm going to give you like 58. All right. So, close.
38.
38. Thank you, ready? Step ahead of me as you. So that's 38. And then I'm going to take, so now I have 5, 9, and 38 here. So division and multiplication have the same precedence, so I go from left to right. So 5 divided by 9 is 0, times 38 is still 0. So I end up with 0. Then when I'm done with that, I got the 0, then I assign it to the variable on the left-hand side. So I'm glad you asked that question because this is the kind of thing I ask on tests. And now you are inoculated against it.
For you, just assign 5 9s and 5.0.
Hey, there you go. And you can use a way to do it that's making a cast. Just put in the decimal point here. Like that. Do that again with it. Well, it's supposed to be good. Well, let's run it to make sure. Now I can see what all the decimal points after the 21 are. So that's casting. There's a new style of C++ casting. I think it's been around since 1999. Both of the double would work just as well. But one of them, sorry, Chris. When just one of them is a double, then the second one automatically gets converted by C++. So if I can manually put it in there, then it'll have the same result.
And
Pardon me? Yeah, that's because we converted the data type here from an int to a double on the earlier experiment. So if I put it back, it would look like that.
Declaring that we can be verified as a double.
Oh, okay. Sure. Okay, I get it. My mistake. And then I take off the 0.0 here and the 0.0 here. That's what you meant? Okay, thanks. We're on the other one, double two. Okay. Of course, we already know that this will affect it because the right-hand side is covered before the left-hand side. You want to find value. It's because of the order of operations here. So this is a double, and it's going to be 70.0, if you will, minus 32, so the 32 is going to become a double. So I'm going to
We ended up with 38.0, if you will.
and then I'm going to start this from left to right. But the division comes first because it's the same precedence as the multiplication. So 5 divided by 9 is still 0.
We're storing into a double and then 0.0.
Oh, why does it come out that way? It's just C++ doesn't put trailing zeros on unless you say space. That's just default behavior to see how. Okay, so there's a new style of casting. So instead of just saying double inside of my parentheses, I can say static cast. And put the double inside of the angle bracket here. And then I can put the 5 inside of parentheses. And this has the same effect for this job. So this is the new style of casting in C++. Compared to the other style, which was just parentheses. So you can use either style. I don't mind either way. And the new style has been around since 1999. So I guess it's not that new. An example of when you might actually use this, I just wrote this little program that takes in hours as decimals and then converts it to hours and minutes. So if I enter in like 1.5 hours, that's an hour and 30 minutes, right? So that's what a computer is doing, 1 hour and 30 minutes. How I did that was I took the input as a double, and then I assigned it to an integer variable. Then I took the input, which is 1.5, and I subtracted the integer value of it, which is 1, and I ended up with 0.5. And I take the 0.5 and I multiply it by 60, and that's minutes. So that was a use for casting. Wasn't that exciting? Everybody managed to keep their eyes open, so that was good. So let's do this one little exercise and then go to break. So this exercise is just trying out these various things. And I think it's a 10-minute exercise and then a 10-minute break. But 20 minutes from now, you should be finished with this exercise and be well rested. Okay, just getting started again. Breaks over. So, are there any questions about the homework here? So, what's the main takeaway? Price of so we use fixed and set percentages in the program. So now, hopefully, we know how to do that. We did some division here and saw that if we have doubles, and that helps make sure we get the right thing. We use a constant, and we use a casting operation here in order to convert price of a double to integer dollars. So this rounded into whole dollars, well not rounded it, truncated it actually, rounded down to whole dollars. So any questions about these little things of C++ arithmetic? And I have one more topic in the numbers area, precision and range. So if you have an integer number in C++, it's stored as a pure binary number. So maybe you remember the Australian guys in the first week talking about binary numbers. So again, this is the first column here is 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, and so on. So you just, there's a 1 in there, you count it, and then you add up every place there's a 1, and you get the value in decimal. That's just conversion from binary to decimal. The first bit is the sign bit, and the others represent the actual integer value. So in C++, we have one bit. If it's a 0, it's plus. If it's a 1, it's minus. So what happens if, so what's the maximum value I can put into a signed integer here in C++? So it's yeah, to the power of 30, 30 again. So which comes out to be about 2,147,483,647. That's as big as possible positive integer you can have. And then you can also have a negative integer that's the same size. So what happens if I take that most positive, the largest possible integer I can have, and I add 1 to it? What does C++ do? And then inherit. That'd be nice. So what does it do? Wraps around. So we have a case of what's known as integer overflow. What does it mean by wrap around? Let's find out. I have a biggest possible positive integer you can have, and then on line 7 I add 1 to it. Okay. And what did I get? The big negative number instead. The largest negative number I can have. So why is that? Well, it turns out that in this diagram here, we're talking about the integer values. I have all of these values in the integer value section will all be 1. Okay? And if I add 1 to that, then I'm going to get an overflow condition because of the way binary arithmetic works. So just to do it on a shorter one here, I have 1, 1, 1, 1, and so on. And then there's the sign bit here. So then I say +1. Well, there's only two possible digits in binary, right? 1 or 0. So if I have 1 and 1, that's going to be 10. You know, 1 plus 1 is 10 in binary. Anybody ever seen that T-shirt or saying that says there's 10 kinds of people in the world, those that understand binary and those that don't? The value 2. So 1 and 1 is 10, so I 0 and I carry the 1. Then 1 and 1 is 10 again, so I 0 and I carry the 1 to the next place. And so this keeps going until I get over to here. So I have, you know, 1 and 1 is 0, carry the 1, 1 and 1 is 0, carry the 1, 1 and 1 is 0. And I carry the 1, this is 0 here, meaning a positive number. And now I've carried the 1 into the 31st place, to the 31st assigned bit here, and so 1 and 0 is a 1. So now what I have is a negative number. Because C++ is stored in what's called 2's complement, where the negative side everything is reversed, and it comes out as the smallest, or the largest negative number you could have. So that's why we did that. That's why that happens in an overflow situation. Questions? What about if I have the largest negative value and I subtract 1? What would happen then? Any guesses? It goes positive. So it's consistent. In that sort of way. So I subtract, a negative number and I subtract 2, and then I get a really large positive number. So whenever you use integer values, you have to be careful with the range. If you're going beyond 2 billion, then you have to be careful. So what's the solution for this? More bits. So let's take the integer bigger than 32, like 64. I think that's sort of the wrong way. Something can't do that. So that'll take you up to some really huge number. It was a time when the size of an int was only 16 bits, so it would go plus or minus 32,000. But because of that, there was this cartoon, they waiting for XKCD, so few people. So here's the cartoon for XKCD. So the guy can't complete the counting sheet. And it gets us to 32,767, which is the largest possible positive value in 16-bit integer. Well, suddenly you go to negative, so he sits bolt upright in bed saying, what is going on here? And it starts continuing on. So I woke up again. Somebody's having a problem. C++ does have other integer types, so to increase the range, it originally had a long data type. Our current version of C++, they left the long at 32 bits when they made the int 32 bits from 16, and so they're both the same size now. We have to go from a long int to 32 bits before I read. But it depends on the compiler that you use as to what the values are. We're going to talk about floating point numbers. So in floating point, we're trying to emulate real numbers, but there's an infinite number of real numbers, so we can't and represent them all in only 4 or 8 bytes of memory. You can't put infinity into a finite space. And so the computer has to approximate it using the floating point format. So there's 3 fields in the floating point format. There's the sign bit, that works the same as for integers. 0 is positive, 1 is negative. Then they have what they call the exponent and the mantissa parts of it. So the mantissa is multiplied by the base, which is 2 because it's binary number, to some particular exponent. So for a float, which is what we have up here in the 4 bytes, it's the same size as an integer, you'll notice that the number of bits designated to the mantissa part is a lot less than you have for the value of an int. Okay. So this part right here is only, what, 23 bits instead of 31 bits. So you cannot have as much accuracy as you would with your value. Because of that, we typically use a double because it has 8 bytes of memory and it's twice as good as a float,
And it has 15 or 16 decimal places of precision.
With a integer, with a floating point, you can have rounding errors, even with doubles. As in one more example, if I add 0.8 and 0.1 together, what do I get? What should I get? 0.9. Well, what do I actually get when I'm dealing with a computer? Well, unfortunately, not what I hope. By the way, does anybody remember the extra credit from assignment 2 where we had 4.35? So the mystery will now be exposed. Okay, that decision was not declared in the scope. What do I have to do? There you go. I opened it. So, when I take these numbers, point F, point 8, if I put an F after it, that's saying that it's going to be stored by the compiler as 4 bytes as a float. And if I add 0.8 or 0.1 together, I don't get 0.9. Instead, I get 0.9000000357627, and on and on and on. So it's only approximately 0.9. And even with the double, out of the 17 decimal points is an error. It's not exactly 0.9, it's 0.90002. So you get these little errors that creep in. Or if I take 4.35, it gets stored as 0.349999999. So I multiply that by 100, and assign it to an integer, I get 4.34. Which is why we had to add on the plus 0.05 to that, and that rounded it up and truncated. Okay. So that's some of the things you have to watch out for. Floating points, they're not always accurate. You have to worry about precision. So integer numbers are exact. A 1 is always a 1. It's not 0.00 or 0.9 or something like that. So the integers are always exact, but they have a limited range. So if you work with a large integer, you have to make sure you don't go outside of that range. Floating point numbers, they have a lot more range. They can count all the atoms in the universe, but it's only approximate. So they have a precision problem. When you have repeated math operations, they become much precise, but they have to be careful about it as far as precision. The questions about numbers and arithmetic and C++. But how many digits can I store in a float? did that to the guy. So, 7 or 8? Then after that, you lose decision. On the double, it's twice that. So, we do 15 or 16. After that, you start having rounding errors. Let's say I have this little bit of code here. So if I take a double and I take the square root of it, and then I multiply the square root times the square root, I'm squaring the square root, so I should get back to the original number, right? So is it exactly equal to 2 though? So we're saying that the square root of 2 squared is not 2, but something else. Let's try it. It's one of those little situations you have to be aware of. So the square root of 2 squared is not 2, but 2.0004. So that's one of the cases you have to be careful in. You're trying to do an equality check. We did equal last week. So these two things are the same, so they're not the same. You have to be careful with this including.
If you declared or the
why not? Because there would be even less precise. -2.0004 is 1.9. So the takeaway here again, integers are precise, but they have a limited range. Floating point numbers
have a bigger range, but they're not precise.
always, not always precise. Numbers are precise, they're not all of them. 0 till 0. Okay, so selection statements. The code executes sequentially one statement after another, and pops to the bottom of the function like vein. Sometimes we want to change this sequential flow, and one way is to use the selection statement. So in a selection statement, I have the word if, followed by a test condition inside of the parentheses. The test condition has to evaluate to true or false. If it's true, then I execute the statement inside of the curly braces. If it's false, I don't. So in here, if 7 is equal if, the same as, then it executes it, otherwise it doesn't. We also have an if-else statement, which will execute the else clause if the test condition is false. So if it's true, I execute this part. If it's false, I execute that part. So it's alternation between the two. This is review. Hope everybody's good with it. Any questions? But in order to make the test condition, we often use a relational operator because they will force a comparison that it will return true or false. So a relational operator has two operands that make up the relational expression, and the count has a value of 4, and 4 would be less than or equal to 5, and I would have a true condition. So I'm always trying to get to true or false. Break it down into something simple enough that a computer can only understand true or false, or 1 or 0 can understand. So I can nest if statements within other if statements. Here's an example of nesting an if statement, an else statement, actually inside of an if statement, if function, an outer if. So this inner if statement will only get executed if the outer if condition here is true. Well, it won't execute it if this condition evaluates the false. Instead, I'll just jump down here to the else clause and say correct. I can also nest in the else clause. Not stuck with just the if clause. And so what I usually do is I have an if statement that's put in the else clause if I want a series of them. And this actually turns out to be quite useful. If this first one evaluates to true, I execute it, your guess is too low, and skip all the rest. If it's false, though, I evaluate the next if statement. If this is true, then I execute the second if clause and skip the else. But if it's false, then I do the else at the end. So I'm going to take the first one that's true and skip the rest. And at the end of the false is I'll use the final else. So this is nesting inside of the else. Yeah. We format it this way so that we can see the sequence that's going through. And also, you don't have all the events going on. Putting out here. So questions on if and else statements? So we can make selections now, right? Natural and otherwise. So one of the things you can do with the if-else statement is you can distinguish between multiple alternatives, like I was describing before. Here's a little program that will say what the value of a coin is. So what kind of coins do we have in U.S. money?
Dollar coin.
Yeah, pennies, nickel, dimes, and quarters, right?
Here's a dollar coin.
Yeah, if you go to Las Vegas, you sometimes see silver dollars. But, you know, they try to come out with dollar coins like the Susan B. Anthony and so on, but they never really
They also have some 50-cent coins.
Oh, they do have 50-cent pieces sometimes. You don't see those very often, do you? So we can add to this. I can add ounce a quarter, I can add 50-cent piece and silver dollar. But, you know, I'm just sticking with the basics here that we mostly see. So if I enter a coin name like penny, this program just says its value is $0.01. If I entered in nickel, which would be this next statement here, then it would say the value is 0.05. If I said dime, it would be 0.10, and quarter is 0.25. So it just goes down the list. The first one is correct. You know, you just print out or assign that value. Otherwise, it says it's not about the coin yet. If I get to the end. Is everybody okay with that if-else structure? What happens to you? Yeah, so it's the exact match here with the string. So you wouldn't get it right. Which is a problem you could run into like in your homework and stuff. So if I run this and I say penny, you might say that's a valid coin name. So what's the matter with that? You know, you would have to be able to make it penny or penny with a capital P or penny with a capital P-E-N-N-Y and all the other variations on penny. So it could be kind of complicated to get all the possibilities. So one trick is to say, it's your coin name in lowercase. Put the burden on the user instead. So here's a flow chart of that penny, nickel, dime, quarter. So if this is yes, and we find the value and go to the end. If it's a nickel, we find the value and go to the end, and so on. short flow charts, there is one. The questions about the series of if and else statements. Okay.
Yeah.
Yes. So I'm declaring this outside of the if and else. And so I'm starting off with the default value of 0. That's why when I said it's not a valid coin name, we gave it a value of 0. Because only if it matches one of these will the value change. So I can change values, of course, with an assignment statement. And the assignment statements will only execute if one of the 4 names is recognized. So it's a good question. Any other questions? What if I have this code here and I enter in $? What's it going to print out? Pardon?
It's not a valid coin name. So it doesn't recognize it. So you can have errors in your program, that's a logic error, right? So you can add in the $ as a possibility.
Which would be pretty easy. I would just take this code and change it to $ and value. If the score is 85, what gets printed out in this snippet of code? And there's some D's buzzing around. You might think of something besides a D. So it's like, is the score greater than 90? False. Is the score greater than 80? True. Therefore, it's a B. So that's how that works. So sometimes when you have these series of test conditions with an else if, the order matters, but sometimes it doesn't. So here's a little program that predicts what will happen based on an earthquake reading of the Richter scale. So I compile it. Hey, compiles must be good. Let's turn it in. And then when I run it, enter a magnitude on the Richter scale. So, is anybody here alive in the Loma Prieta earthquake? Besides me? Few people? Okay. But it was a pretty exciting day. I mean, I was working at this little company called Seagate,
And we were on this conference call with Singapore. And the room starts shaking, and they had this big round table in the middle of it.
And so I did what you're supposed to do when there's an earthquake. You get under the table. Only this was a pedestal table. It just had a single pole in the center, holding everything up. So I ended up holding up the table throughout the earthquake. Glad the ceiling didn't fall on the table and put some extra weight on my back or something, you know.
There were a few smart people who got in the doorway, but doorway will only handle a few people in a room full of people.
So anyway, power was out for 3 days. I got 3 days off work, which is great. Of course, they ran some generators at the store so you can get through that after a day or two. Walk through downtown Santa Cruz. Anybody ever walk down the Pacific Garden Mall? It was just rubble everywhere. All the buildings had collapsed, or most of them collapsed. Bookshop Santa Cruz had collapsed entirely. And they were in a circus tent for over a year where they built a new building. It's pretty crazy. Anyway, so if we see the earthquake was a 6.9 magnitude earthquake. So many buildings considerably damaged, some collapsed. That's described in Pacific Garden Mall. Exactly. Some of the buildings were damaged and some collapsed. I think a different value. It was the biggest earthquake ever recorded. Anybody know? See, there was one in Alaska. It was 9 point something. We call it 9. All the structures fell down. All the equipment and everything was gone. I can't believe I'm recording when I say that. They said that the earthquake was so bad, it went on and on and on for like 5 minutes. After a while, people got tired of standing at the floor and they just stepped back down on the couch. And the couch moved all around the room, you know. It was like a ride at the boardwalk or something. So the order of these statements matter. If I change the order, I'm just going to switch them. I just happen to have the code here to do that. So I'm going to start at 0 instead of starting at 8. Now if I run it, okay, messed up. I was also to replace this part of it, not the whole thing. There we go, we're better. So if I enter in the 6.9 for the lower pre-added earthquake, that's generally not felt. Let me assure you, everybody felt it. Even if you were passed out drunk, you felt it. May not bother you in that case. So the tester is the wrong order, then makes a difference in what this program does. Also, what if I just say, hey, I'm not going to use if, else, I'm just going to use a bunch of different statements. So here I have it in the right order. I say, hey, if the Richter is greater than 8, the structures fall. If it's greater than 7, many buildings destroyed. It's just a bunch of if statements without the consequences. What effect does that have? So if I compile this, as expected.
You didn't fully copy it on the last count.
Oh, the last CS messed up. It's better than the composite because you actually tell me what's coming. So here I enter a magnitude of 6.9. And yes, many buildings considerably damaged, some collapsed. That was true. Then it goes on to say damage is probably constructed, felt by many people, and the destruction generally not felt by people. So I think the issue is honestly true. But not a very good choice in that case. So sometimes you need to felt this structure and sometimes it has to be the right way. Sometimes it doesn't. Like pennies, nickels, dimes, and quarters didn't matter which order it was at, but it was tells you the Richter table. So let's do this little exercise here. I think it's a 5-minute exercise, and then we'll just take a break. So 15 minutes from now, you should have this exercise done, followed by the rest time, so you can come back over it. Boolean variables. So sometimes you need to evaluate a logical condition in one part of a program and use it other places. And if we want to store a condition that can only be true or false, we use what's known as a Boolean variable. And Boolean variables are named after George Boole, who is this friendly looking guy here. And that's the way they dressed was back in the 1800s. Quite fashionable for his day. And so he was an early pioneer in the study of logic. And so Boolean variables are named after him. Of course, in C++, we shorten the word Boolean to bool. We lost some of the letters, right? And then you declare a variable, and you can only assign the value of true or false to the variable. So what type of test does George Boole give? He was actually a professor. True, false, that's good. So how did George Boole order lunch? So he points to each item on the menu and says, no, no, yes. And you can do a lot with Boolean variables. In fact, the computer is based upon Boolean values throughout it. Binary bits, ones or zeros. The 1 is true and the 0 is false. So the whole computer is based on Boolean. We can use it in programming, because it's pretty easy for the computer. We say, like, if the number is greater than 0, well, it's either going to be true or it's false. So then I can actually save this relational expression here in a Boolean variable, and then all I have to say is if, and I use the name of that Boolean variable, and what's the value of the Boolean variable going to be? One of two possibilities, right? True or false. So if it's true, I execute the if positive. If it's false, I don't. So you can have a test condition as short as just one word. Variable. Because a Boolean variable always evaluates true or false. Well, I don't need to do things like if this positive equally true, because this positive was already true or false. So it's just kind of a way to do this. Same thing with not equal false, same kind of thing. We just have a single test condition. So here's an example of a program that uses a Boolean variable. Not very exciting program. So I enter a number. That's something. And if it's that test, is the number greater than or equal to 0? And so I assign that value to is positive. So if it's less than 0, it's going to be false. If it's greater than or equal to 0, it's going to be true. And then down here in my if statement, I just use the value of is positive to decide if the number is 0 or positive or negative. So, what's a good number to test it with? 42, I'm glad you suggested that. This is true, and so is 0 or positive. So a negative number, minus 11. So that was false test condition, and then a number was therefore negative. Sometimes we need to test for multiple conditions in a program. Like we want to test if an age is between 18 and 25. Maybe get an extra discount or something like that. So you have to test both if the age is greater than 18 and if the age is less than 25 to get the special discount. So if you can do this as a nested if else, and it will work. But it's kind of lengthy, just make it stuff like that. as 18, then I have a good age. But more than 25, it was a good or less than 18. Well, one way, instead of using nested if statements, is we can use what's known as a logical operator or Boolean operator. And this is an operator that has a value on either side, and the value on either side has to be true or false. And so if I have an expression where it's true and true, like 5 is less than 10 and 5 is greater than 2, then it's going to come out that the entire thing is true. So true and true will be true. But if one side is false or both sides are false, it's going to come out as false for the entire thing. Logical operator. So if I had age greater than or equal to 18 and age less than or equal to 25, so if I had age greater than 18 is true, and I might have age less than or equal to 25 is true. An example of that would be what? 20 greater than 8 equal to 18, less than or equal to 25. Okay, so true and true. So I test both conditions with an and between it. And what if I was greater than 18, like 42? What would be the value of age less than or equal to 25? False. What if the value, what if the age was 7? False. Would this be false? And would this be true or false? It'd be true because 7 is less than or equal to 25, right? And if I had, I argue both of them to be false. Something that can't be. If age is greater than 18, it's false, so that would be like 7, and this can be less than 25, so I guess I can't show that particular condition. So if this is true and true, then the whole thing is true, but if either side is false, it's going to be false. So I can't come up with an example for the false condition. Is everybody good with and? If both sides are true, then the entire thing is true. Otherwise, if either side is false, it's false. So they can leave the true or one the false and 0. You could think of it that way. So think of 1 as 0. Yeah, it has to be close plus stores it. So for a OR operator, which in C++ we spell, the old way of spelling it with 2 vertical bars, but we can also use the word OR instead. So if I made this a 4, then, if this is true or this is true, then it's going to be true. And if either one is true, the whole thing's going to be true. And only if both are false, then will the whole thing be false. So that's a OR operator. And here's a truth table for it, as an example. And the not operator is just negates the value. So the not operator is like the old not joke. Anybody remember?
Both, like your nut is ugly. Not. So you say they're not really fast,
They don't get punched. Might get punched anyway. So it just reverses. So here we have an example where we're going to test our age. And here we're just going to say if the age is greater than or equal to 18 and the age is less than or equal to 25, then it's correct. Otherwise it's not correct. So let's compare this. We have this with this. Notice how much shorter it is if I don't have to do the decimal. So this whole part right here gets replaced what the logical operator. Lift that up. Like so. So it's a lot shorter. When I run it, your age is 20, and the correct age. And if I run it and your age is 7, then the wrong age. You could reverse that. So I could use an OR, and I could say, and switch the relational operators here. The age is less than 18, the age is greater than 25. And that would give you the same result. So a lot of people get confused about the and and or conditions, and there is no absolute formula. A value lies between 0 and 100 if it's at least 0, and at most 100 if it's outside of that range if it's less than 0 or greater than 100. So no goal will always have to test your conditions. Any questions? Okay, another way to look at truth tables is you can do a manual assessment and substitute ones or zeros for it. So if we do so, then the and is like a minimizing function. So if I have a 0 for false and a 1 for true, then 0 and 0 is going to be 0. But a 0 and 1, the minimum of those two is going to be, what's the minimum of 0 and 1? Oh, 0, so it's going to be 0. 1 is 0, the minimum of that is 0, so that's 0. And then 1 and 1, the minimum of that is 1. So substituting true and false for that, and I come up with the and table, or as a maximizing function. And of course not just reversing it. So I don't know if that helps or not. We have an opinion this later now that the problem. Yeah, don't be so obvious about your ability. And you're cold. Okay, I'm just backing things up. Okay. So I have a little example program here. There's some movies on it. I suggest you look at these movies. I want to mark where they are. I don't think we have time to go through this little test here, so I'm going to let you watch the movie instead. There's one more exercise where you get to use logical operators. So this is a simple food guide that, depending on if you're hungry and what the temperature is outside, it makes a suggestion on what you should eat. So if you're hungry and the temperature is greater than 100, you want to eat ice cream. So if you're hungry and the temperature is below 0, you want to eat some spicy foods. Warm you up, right? And if you're not hungry, don't eat. Otherwise, go ahead and eat whatever you want. So that's a series of logical operators with relational operators and different elements. There's some common pitfalls. People often forget to put equal. They just put a single equal sign, and so that will give you unexpected things with C++. It would actually assign the value 7 to get. And in C++, any number that is not 0 is considered true. So that means you get equal 7 will always evaluate to true. And it's very confusing. So remember to always put equal. And so what I have to do is I reverse the equal to say put the number on one side and the variable on the right-hand side, and that way this will multiply if it's wrong. You can also have these strings of inequalities that could be a problem. So you have to actually have two sides to each operand, and this ends up actually compiling C++, but it doesn't give you the answer. It's actually the logical operator on each side of this whole relational expression. And strings of inequality can be a problem too. I'm going to let you read over that. And then I want to talk about loops. So when you want to repeat a section of code, you use a loop. Should I repeat that? If you repeat a section of code, you use a loop. Remember Mark Zuckerberg?
First thing, you get really bored if you have to do the same thing lots of times in a row. But a computer can do the same thing millions or even billions of times and not get bored and be able to carry that out really well. So for example, if I wanted to wish everyone on Facebook a happy birthday by sending them an email, it might take me more than a century to actually write out all of those emails to everyone. But with just a few lines of code, I can have a system sending emails to everyone on Facebook wishing them a happy birthday. So that's what loops are and why they're valuable and that computers can do it very well. In this example, your goal is going to be to move Missouri. Now, we're going to be able to use the repeat block in order to be able to do this very easily. You can either do this by giving the computer a move forward command 5 times in order to advance the verb one step each time it's made, or you can just tell the computer to move forward once and then tell it to repeat that 5 times, and it'll do the same thing. So in order to do this, you grab your move forward command, and then you put it inside the repeat block. And you can click on it and tell it how many times you want to repeat the block, about how many steps you want to take forward. Now one more thing is, you can put as many commands as you want inside the repeat block. So in this example, you're telling it to move forward and turn left, which will do 5 times. All right, good job, have fun.
Have you ever doing that on the first week?
Yeah.
Okay. So what do you think? Was it worth seeing Mark Zuckerberg again? Okay. So there's 3 general purpose loop statements in C++. There's the while loop, there's the for loop, and then there's the do while loop. So we're going to start with the simplest one, the while loop. So the way a while statement works is, there's the word while, then there's a test condition. If this is true, it repeats the statement inside the test condition. If it's false, skips over and goes on to the next statement. So it's just like an if statement, except it uses the word while here. The only difference between a while and an if, besides the word name, is when you get to the end of the while loop, you go back up and you start over again. So somewhere you better make sure that that test condition can evaluate the false, otherwise you will have used the truth. Here's the flow chart for it. So while some condition is true, I'm going to execute the body of the loop and then go back up and start over again. So there's a flow chart. If the condition is true, I'll do the body and then start over again. If that ever becomes false, I'll continue on to the next stage. So here is a while loop, and this is a very momentous time because this is the first time we're playing an exciting game. Okay. Wow. Now I'm playing an exciting game. Do you want to play again? Sure. I'm playing an exciting game. Do you want to play again? I'm playing an exciting game. Do you want to play again? I don't think it's so exciting, so I'm going to say a lot. But I'm repeating. Notice I'm just repeating the same thing over and over again. Well, that's what a while loop does. It repeats until the test condition becomes false. And somewhere in there, you're going to have a way to go ahead and be able to change the test condition from a true to a false. Otherwise, you have a loop that goes on forever. So, like most other statements, there's a pair of curly braces that have curly braces. You want to indent inside of the curly braces. So it's placed rather like an if statement is. So there's one last little exercise to do. Remember the guessing game with the number, our first game? So we're going to add a while to it. So you can do that at home as part of the homework. Have any problems? No, we get to help on. Here's the code at the end. This one looks a bit false. I'm going to let you read over that because I think everybody's anxious to go. Brad?
What if they're infinite loop? What do we do?
You do control. That's a stand around. Or you put a little bit. Does anybody want to hear about the homework? You just continue as late as you want. If you're going to read just do it quietly. So the homework. There's 3 programs. Just the usual preparation and tutorial labs and all that. There's 3 programs. One is